Hi, so welcome to today's session where we're going to be looking at Poisson probability distribution. With today's session as well, you need to have your statistical tables with you because we're going to refer to them. Today we're going to use the Poisson table. By the end of the session today, you should be able to know and understand the properties of a Poisson probability distribution, how to calculate the mean, the variance, and the standard deviation of a Poisson distribution, and also how to calculate the probability of a Poisson probability distribution. And remember also, when we calculating the probability, you will always have to remember the sign with the meaning, and if possibly, how to link a word phrase to the sign and the meaning. Okay, so when we talk about a Poisson distribution, it is a process that comes from a continuous process. Let's put it that way. It's a where things happen on a continuous basis. For example, if I work in a shop and I want to count the traffic, I can stand there and count how many number of people comes into the store. And because I'm doing that on a continuous, I'm counting on a continuous basis. And after an hour, I can say on average, we get about 20 people coming through into our store if I'm in a retail, or if I'm in a slow moving goods type of a retail, then I might say on average we have 1.5 person coming through into the store, and I can calculate the probability of maybe getting more people or getting fewer people or more a certain number of people into the store. Maybe probably I want to run promotions, and I can use the probability to predict all those, or to find the probability of getting those people into the store. So that is the Poisson distribution. You use Poisson distribution when you are interested in the number of times an event occurs in a given area of an opportunity. And when we talk about the area of an opportunity, this will be a continuous unit or an interval time, or a volume, or an area. It can be even, it can be something that happens more than once as the process continues. For example, like you can count the number of scratches in a paint car, in a car's paint. For example, if you work in an auto body, or in a dealership where they repair cars, you can look at the number of scratches a car comes through with, and so on. The number of mosquito bites on a person. So if you live in an area where it is mosquito infested, you can also look at a Poisson distribution of that mosquito bites, or the number of computer crashes in a day. And this will be, if you work in an IT environment, then you can also use Poisson to find the probability of having your computer crashes per day or in a day as well. So a Poisson distribution is also one of those important probability distribution that you can use, the same way as we discussed the binomial, which you can use for the lotto with Poisson as well. Even though it's from a discrete event or a discrete variable, but you are able to calculate that probability as well. So when it comes to Poisson distribution as well, you should be able to calculate the mean of a Poisson, which we refer to the expected mean, or the mean, or the mu, and is denoted by a lambda, which is your average time. And the variance is equals to your sigma squared is equals to the lambda, and your standard deviation will be the square root of your lambda. Therefore, for a Poisson distribution, you need to always remember that the mean and the variance are equal. They mean the same thing. in a Poisson distribution, and the standard deviation is the square root of the variance, or is the square root of the lambda, or is the square root of the expected number of events. Right. Let's look at an example. A local police station receives on average 3.5 emergency calls per hour. These calls are Poisson distributed. And this is another thing. In most cases, in your assignment or in your exam, they will mention the word Poisson, so that then it makes it easier for you to understand that the information you are given follows a Poisson distribution. So in this instance, we are told that our average is 3.5. And the question says, find the mean. And we know that an average from measures of central location, we know that the mean is the same as the average, is the same as the mean. So find the mean, and we know that the mean is equals to the number of events, and our mean in this instance will be equals to 3.5, which is the number that they have given us. Find the variance. Our variance will be 3.5. And find the standard deviation. Our standard deviation will just be the square root of 3.5, which then it is equals to, need to get my calculator, the square root of 3.5 is equals to 1.87. 1.87. That's easy, right? So with Poisson distribution, you should be able to calculate the mean, the variance, and the standard deviation with ease if you get them in the exam or your assignment. Okay, so let's move on and talk about how do we find the probability. I just put this slide on. We've been talking about this slide for the past 2 sessions that we had. So you always constantly have to remember this. You have to remember how to match or read a symbol with its meaning. And if they give you word phrases, how to link that word phrase to a symbol so that you can answer the probability question. So we're still going to work on this. If you are new to this session, please take a screenshot of this, because we're going to use it when we do the activities as well, so that you are always aware in terms of the questions that they are asking you, whether are they asking you to calculate at least, at most, more than, below, exactly, between. You need to know how to link those words into the meaning of less than or equal, greater than or equal, or between. And also when it talks to between, whether is it between inclusive and between exclusive. Depending on, inclusive means there is an equal sign to it. Exclusive means there is no equal sign to the side. Okay, so based on this, we can then go and answer our question. So in order for us to calculate the probability of a Poisson distribution, then we will need to calculate it using this formula. The probability of an X observation following a Poisson distribution is given by your E base of natural logarithm, which is E to the power of minus our number of expected events, which is lambda, times the lambda to the power of your X, which is your number of events, divided by your X factorial. So how do we answer questions like this? For example, if the question says, find the probability that X is equals to 2 when the mean or the expected number of events, or the number of the mean is equals to 0.5, then we need to take the information given, substitute it into the equation, and calculate. The most important thing is the sign. The sign says exactly or equal. So it means we're going to calculate at that point. So we're going to substitute the value of x is equals to 2 and our lambda of 0.05 into the formula and calculate. Now, when you look at this e to the power, on your Casio calculator, your e to the power will be e. You will have to press the shift button. It will have a block on it. That's the value you're going to use to calculate the E. For those who are using a Casio, not a Casio, a Sharp or a financial calculator, yours will be written like e to the power of x. Look for it on your calculator, and if it's written in orange, you're going to press shift for a Casio. If it's written in orange for a Sharp or a financial calculator, you are going to press second function so that you can reach that number. Okay. So how do we answer this question? So I'm going to substitute. Our E is a base natural logarithm. So our lambda, it's 0.5. So it's minus 0.5 times 0.5 to the power of 2 divided by 2 factorial. And when you solve this entire equation, you get the probability of 0.0758. Now, the challenge is, what if they would have said, we need to find the probability of x is greater than or equals to 2. Therefore, it means we're going to use this formula to calculate the probability of x is equals to 0 plus the probability of x is equals to 1 plus the probability of x is equals to 2. So you will have to calculate for all three probabilities, so then add them together. It's the sum of all the probability of x less than or equals to 2. The easy way, so that then you don't get confused with formulas, you still need to know how to use the formulas. But the easy way, especially in the exam, is to use the table. Hence, we're going to introduce the Poisson table. So a Poisson table, it looks different to the binomial table. So with the Poisson table, it's divided. The table is divided by the lambda values, or your average values, or your mean values. So your mean values, you will see them at the top. And for every mean table value, notice that there are some mean values and they end at some point somewhere, and they have the corresponding x variable on your left. And for every table, the number of x values differs or increases with each table. So you will need to pay attention to that. Okay, so how do we answer this question that we have? We know from the formula we get the answer of 0.0758. So on this, we go to where x is equals to 2. Then we go to lambda is equals to 5, 0.5. And where they both meet, that is where the probability is at. As you can see, there is our probability. Easy. Instead of using the formula to calculate, we can come to the table and answer the question. Easy, easy for easy. Hey, any questions? Are there any questions? You guys
All
are
good?
still here. Oh,
All good.
okay. I thought you left me here alone. Okay, so let's go and do some activities. Let's work through some activities. So this is where you get the chance to do the activities, right, yourselves. So suppose that the number of daily fake news posts is Poisson distributed with the mean of 0.2 posts per day. What is the value of the mean and what is the value of the standard deviation of the number of posts? Remember, your mean is your lambda, your standard deviation, which is sigma, so the mean, and I'm giving you answers, is the square root of your variance. So let's do the calculations and you tell me which one is which. What is the value of our mean?
0.2.
0.2. And if the value of the mean is 0.2, therefore it means we're going to find the square root of 0.2. And what is the square root of 0.2?
0.44.
You can leave it to 1 decimal because I can see most of the answers are in 1 decimal. So the answer will be 0.4. 0.4. So let's see. The answer will be option number 1. That was easy, right? Straightforward and easy. Recent reports of self-driving car crashes have resulted in safety concerns and consequently a delay in their rollout. Suppose the number of crashes is Poisson distributed with the mean rate of 0.1 crashes per day. What is the probability of having only one self-driving car crash in a given year? How do we find this probability? What does only one would mean in terms of if we're going to write it in a probability function? Is it less than, greater than, or equal, or less than or equal, or greater than or equal? Only equal. It will be x equal. And what is our lambda?
0.1.
Lambda is 0.1. So those who wants to use the formula, that will be the formula. You can even write it, some books or sometimes they write it like this. It is still the same thing. Because anyway, lambda multiplied by the E, it's still going to give you the same answer. So those who are calculating it manually, then our lambda is 0.1 to the power x is 1 times e to the power of minus 0.1 divide by 1 factorial. And if you go, those who have a Casio calculator, then you can use your fraction button and do 0.1 to the power of 1 is the same as 0.1 times e to the power second function e to the power of minus. And when you use the minus, remember on some of the calculator, on the sharp calculator, it's a plus or minus. On a Casio, you must use the negative sign in the bracket. Divide by 1 factorial will be a factorial. It is x factorial on Casio or n factorial on a sharp calculator. You need to be able to locate and know where all your signs are on your calculators. Okay, so, and the answer there will be 0,0905 if I leave it to 5 decimal. And the answer would be option number E. Now, I want to also take the same information and go and use it and find the value from the table. So our table, we need to go to a table E7, table of Poisson probabilities. You will see that it's broken down by lambdas and the x values. We are looking for the probability of x is equals to 1 and our lambda is 0.1. So our lambda of 0.1 and x is equals to 1, and you can see that we get the same answer. Are there questions? Is it clear?
It's easier on the table.
Easier on the table, yes.
Easier with the table. Okay, so let's go to our next question. So now, the other thing is, don't feel comfortable using the table because sometimes you get questions like this. As you can see, this, we do have option 4 on there with some formula. But before we get to the formula, let's read the question. The average number of adults with ASD consulting with a neuropsychologist per day is Poisson distributed with the mean of 1.5. What is the probability that on a given day, a neuropsychologist will consult with only one ASD adult? What is our lambda? That's everything you do. You always have to identify the facts given in the statement. So you identify that is your lambda. Only will mean equals to 1. So it means we need to find the probability of x equals to what we dealt with it previously. So if, let's say we're going to jump straight and go and use the table. So if we're going to use the table, we're going to go to the lambda table where the lambda has 1.5. And we need to find the probability of x is equals to 1. And where they both meet, which is at that point. That will be our answer. Can you see that? It is 0.3347. Right, let's go back to our question. We got the answer. Probability of x is equals to 1 is 0.3347. And I look at my answers and you will automatically say, there are no answers here. And you will go to this one and say, need more information to calculate because that's the possible only answer you might want to. But that is not because we're forgetting the formula. So if you, the first point is to go to the table, see if you can get the answer. If you can't get the answer, let's continue and use the formula. X is equals to 1 of e to the power negative lambda. And you can see that I am changing my thing again. So let's rewrite it in this, the previous way. Lambda x e to the power negative lambda divided by x factorial. Substitute the values onto the formula. We have all the information we need. Our lambda is 1.5 to the power of 1 multiplied by e to the power negative 1.5 divided by 1 factorial. Let's see, is it the same? Yay, it is the same. And your answer will be option 4. Easy, right? Or complex? Especially when they include, yes, especially when they include like formulas in the mix. Okay, let's look at our last question. Today we're gonna end this session early. So this is our last session. Suppose now we have knowledge that the number of grade 11 absences at one of the school are Poisson distributed with the mean of 2.5 per day. What is the probability that at least 2 grade 11 learners are absent on a random day? Going to our statement. What is our lambda?
2.5.
2.5. And what does the question ask? What is at least? Now, link the width to the meaning and then to the sign. What is at least?
Is greater than or equal to.
Correct. Probability of x greater than or equal to 2 is what we are looking for. Now, here is the catch with this. because with a Poisson, you don't know how many X values are there, then it means you are going to calculate the probability of X is equals to 2, because it includes 2, plus the probability of X is equals to 1, not 1, 3, plus the probability that X is equals to 4, plus until, can you see? You're gonna go, 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 and go, 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 until. Alternatively, we can use the complement of it, because finding the complement by subtracting the complement from 1, we will get the probability of X greater than 1. So in a way, what I'm trying to get to is you've got one choice of doing this answer, and the other choice is to say the probability of X greater than or equals to 2 is the same as 1 minus the probability of X less than 2, because less than 2 is a complement of greater than 2. If you combine both of them, they will give you the whole sample space. So in this instance, therefore, it means I need to find 1 minus, I'm going to put everything into the bracket because it says less than 2. Therefore, I have to go and find the probability of X is equals to 0 plus the probability of X is equals to 1. And close the bracket. As you can see, instead of doing all the other numbers, which I don't know when I'm going to stop, I can do the alternative of it. So in this instance, you will say 1 minus, and if we were going to use the formula, you were going to say, let's start with 0. So our lambda is 2.5, 2.5. So we're going to use our formula of lambda x e to the power minus lambda over x factorial, right? So lambda to the power of 2.5 to the power of 2 of 0, because our x is 0, times e to the power of minus 2.5 divide by 0 factorial. Don't have enough space, plus, and then we do the same on this one. It will be 2.5 to the power of 1, because our x here is 1, times e to the power minus 2.5 divided by 1 factorial. Just want to calculate. Yes.
Lizzie, how did you get to the 0 factorial?
Because I'm calculating the probability of X is equals to 0.
Okay.
Right? So you're going to substitute everywhere where you see X on the formula, you're going to use 0. When you do X is equals to 1, where you see X, you're going to put 0. So this is the alternative way of answering it, because I'm answering using the formulas, right? We're going to go to the equation, to the table just now. So let's do the first one. It is 2.5 to the power of 0, which will be equals to 1 to the power of 0. Any value to the power of 0 is the same as that value. So multiply by e, shift power e to the power of negative 2.5 divide by 0 factorial. Shift factorial. And the answer here is 0.0821. I'm going to keep it for decimal. 0.0821. And we do the same with 1. And the answer for 1 is 0.2052. Add both of them together. 0.0821 plus plus 0.2052. And the answer we get for the probability for this is 0.28. Subtract that answer. Since I don't have enough space, I'm going to write like this. 1 minus 0.2873. And the answer I get is 0.7127, which is option 1. Now, I've shown you the complicated way of answering the question. If you are using a formula, let's go and look at how we answer the same question when we are using a table. Okay, so now, because now I've got an exposure of a table, it's easy to find my probability. Remember, I said you've got the first choice or the second choice. We can start with the first choice on the table because now I know it ends at 12. So the probability of x greater than or equals to 2 will be the probability of x is equals to 2 plus the probability of x is equals to 3 plus until the probability of x is equals to 12. I'm not going to write all of them because I'm not interested in all of them. I'm going to use the table. X is equals to 2.5 or lambda is equals to 2.5. That's what we were looking for. So that is that. So I'm going to go to 2 and I will have to include all these values. So I'm just going to go there. So it means I must add all these values. So let's start adding them. 0.2565 plus 0.2138 plus 0.1336 plus 0.0668. Just give me a second and you continue finding. Okay, and then you continue adding. And the answer I get is 0.1. So I get the answer of 0.7127 when I add all these values that I have. Okay, so that is one way of answering it. So let's look at the second way of answering this without using the formula. So we're going to say the probability of x greater than or equals to 2. We said it is 1 minus the probability of x less than 2, which we said it is 1 minus the probability of x is equals to 0 plus the probability of x is equals to 1. Now, it is the opposite. So there are only 2 of them, right? So we just going to say 1 minus 0. Oh, sorry. 0.0821 plus 0.20552, which is equals to 0.7127. That's the same thing that we've calculated. Remember, from the formula, we did calculate those 2 values. We found them that they are the same. Also on here, you can calculate both of them and you will find that they are the same. Then this will be 1 minus 0.2873, which is 0.7127. And that's how you do Poisson. I know that the second method might be a little bit confusing, but instead of saving time, calculating and adding all the values from 2 until 12 can save you just by using the complement event or the complement probability, right? Which the complement of greater than 2 will be less than 2. The complement of greater than 2 can be less than 2, or sometimes you can write it as, if you don't want to write it this, it will mean one and the same thing as well. You can also say it is 1 minus the probability of x less than or equals to 1, because then it includes 1. That is also the same, because the probability of x greater than or equals to 2 plus the probability of x less than or equals to 2 is equals to 1, or the probability of x greater than or equals to 2 plus the probability of x less than or equals to 1 will also give you 1, because it's the entire samples, it's the entire table. If you add all of them, they will give you 1. So find the one that you feel comfortable working with, whether you want to add the entire table or you want to use the complement. And when you use the complement, always also remember that what you are trying to achieve with that. What is the sign? If I combine both of them, will they be greater than or equal? Because if I put less than or equals to 2 on this one, yeah, then it will not be equals to 1, because I'm repeating 2 twice. 2 will be in there and 2 will be in there. Hence, it is less than or equals to. And if I do it this way and I remove the minus, the equal sign there, it means I'm not counting 1. So I'm counting the others, but excluding 1. Because on here, it starts from 2 goes up, and then this one says starts from there going up, and it doesn't take into consideration 1. So you need to always be mindful of the signs you are using. On that note, since we finished early, 10 minutes earlier, are there any questions, comments, query?
Yeah. Hi,
Yes.
Vivi.
Mm-hmm.
Can you please try to explain again on that one of 1 minus probability of x less than 2? Where did you get that one? Where
Which
does it
one?
come from?
Which one now?
Can you see second method?
This one.
Yeah. Where did we
That's,
get that 1 minus probability of x minus less than 2?
yeah. So if I look at this table, if this was A and this was A complement, we know that the probability of A is equals to 1 minus the probability of A complement, right? That's all what we know. Otherwise, we can also do it the same thing, vice versa. If this is A and this is A complement. Now, our A, it's all these values that are from bigger than or equals to 2. That is our A. So these are our probability that X is greater than or equals to 2 makes up A. And that's what we got there. Our A complement are events or probabilities that are not included in 2, but are also part of the sample space. And hence, we deal with basic probabilities, chapter 4, information as well. So if I remember that everything under 2.5 makes up 2, because the sum of all the probabilities should be equals to 1. So the complement of A will be any other probability that is not included in A. So what are those that are not included in A? it will be everything less than, everything that is below 2, right? So which is the probability of X less than 2. If I add both of them, the sum of them should give me 1. And that is why if we came to this point there, if I want to find what is the probability of X greater than 2, then I'm going to take the probability of X less than 2 and move it over. The sign is positive. When I move it over this side, it becomes negative, and the formula will be written like this. I didn't want to go through that whole process of explaining, but there we go. That's how I get to the probability of 1 minus the probability of X less than 2. It is the complement of the other one. I'm not sure if I'm even confusing you more.
No, it's okay, because I was confused. Where did you get it?
Yeah, okay. Right, so on that note, thank you for coming. But before you leave, for those who don't know me or where we're from Pambili Analytics, where we're trying to bridge the gap on data literacies, numeracy, and analytical skills. And we do this from a range of services that we offer with our flagship service, which is skills training and development. Currently, in 4 days, the special will end. We are currently offering 150 per hour special on any consultation on anything you want to consult on. Otherwise, you can gain access to the recordings via the YouTube. Remember to subscribe so that you can get notification. If you are interested in getting the recordings of all the sessions that we are having, you need to join as a member. And these are the membership. We've got 5 types of membership. The first 2 don't give you many benefits, but this 3 gives you a whole lot of benefits. So try, and you can see that you will be saving because this is per month. It's not per hour. So you only pay once of $79.99 per month to gain access to massive recordings that are there, that exist, as compared to you paying 150 per hour. You will gain access to all the recordings for only 80 rands. Otherwise, we do appreciate and all the members and everybody who subscribe. Yeah, we have reached 1,575 memberships to date, which means the time we started with the sessions, we gained almost like 105 or 100 and something more people. So yeah, I really appreciate everybody who goes and watch the videos, and remember to like our videos and share with others so that they can also benefit. And over and above, I would love to give a shout out to our members, especially Jeanette, Joannette, Koji, and Knox for being our loyalist members. We really appreciate your support, but not forgetting our supporters and our cheerleaders who are also part of our membership community. We really, really appreciate your support and continue doing that. You give us energy. You give us the courage to continue doing this, even for others to come. Thank you very much and enjoy the rest of your weekend. If you want to get hold of us, those are our contact details. You can reach us on WhatsApp or via the email. Thank you and have a lovely weekend. Bye.
Thank you, Lizzie. Bye. Bye, everyone.
Bye.